In this video, let us learn about service design.
Availability management, goals and objectives. The goal of availability management is to ensure that level of service availability delivered in all services is matched to or exceeds the current and future agreed needs of the business in a cost-effective manner. Availability is one of the most critical parts of the warranty of a service. If a service does not deliver the levels of availability required, then the business will not experience the value that has been promised. Without availability, the utility of the service cannot be accessed. Availability management process activity extends across the service lifecycle. The objectives of availability management process are to produce and maintain an appropriate and up-to-date availability plan that reflects the current and future needs of the business. Provide advice and guidance to all other areas on availability-related issues. Assist with diagnosis and resolution of availability-related incidents and problems. Assess the impact of all changes on the availability plan and the performance and capacity of services and resources. Ensure that proactive measures are implemented to improve the availability of services wherever it is cost justifiable. In short, availability management should always ensure that the agreed level of availability is provided. The measurement and monitoring of IT availability is a key activity to ensure availability levels are being met. Availability management, basic concepts. Let's have a look at the few key concepts of availability management. Availability. In simplest terms, the ability of a service, component or CI to perform its agreed function when required. This term answers the question, is it available to use when needed? Reliability. A measure of how long a service, component or CI can perform its agreed function without interruption. When we understood availability, the question comes, how long the service will be available for? This can be answered by reliability. Maintainability. A measure of how quickly and effectively a service, component or CI can be restored to normal after a failure. The emphasis is on how soon or how quickly the services can be back to BAU. Serviceability. The ability of a third-party supplier to meet the terms of their contract. Often this contract will include agreed levels of availability, reliability and/or maintainability for a supporting service or component. Serviceability and maintainability are often confusing terms. However, the key differentiating term here is involvement of third-party suppliers to restore the service or component. Understanding basic concepts of availability management. Let's understand these four terms with the help of this figure. Availability, reliability, maintainability, serviceability. Take an example of a typical incident life cycle. The moment incident is detected and it is restored, delta of that time is called MTTR, or mean time to repair, and can be termed as the serviceability if a third-party supplier was involved. After restoration to the occurrence of the next incident, the time when service was available to use is known as MTBF, or mean time between failures, and can be termed as availability. Maintainability can be explained by time taken to repair. Shorter the time, greater the maintainability. And finally, time period between the two incidents is known as MTBSI, or mean time between system incidents, and can be termed as reliability. Components with a high reliability factor mostly remain in high demand, like some companies provide MTBSI ratings along with their networking components, such as routers. Availability management, key role. The availability management process includes two types of activities. Reactivate activities. These involve the monitoring, measuring, analysis and management of all events, incidents and problems involving unavailability. These activities are principally performed as part of the operational roles. Proactive activities. These involve the proactive planning, design and improvement of availability. These activities are principally performed as part of the design and planning roles. The key role is availability manager, who is expected to be involved in the activities like responsible for availability management process, participates in IT infrastructure design, monitors actual IT availability achieved, creates, maintains and reviews AMIS, an availability plan, availability testing schedule, testing after major business change, assesses impact of changes on availability plan, attends CAB meetings, ensures cost-justified levels of IT availability, assessment and management of risk. Capacity management, goals and objectives. Capacity management. Capacity management is a process that extends across the service lifecycle. A key success factor in managing capacity is ensuring it is considered during the design stage. It is for this reason that the capacity management process is included here. Capacity management is supported initially in service strategy, where the decisions and analysis of business requirements and customer outcomes influence the development of patterns of business activity, lines of service, LOS, and service options. This provides the predictive and ongoing capacity indicators needed to align capacity to demand. Capacity management provides a point of focus and management for all capacity and performance-related issues, relating to both services and resources. Like availability, capacity is an important part of the warranty of a service. If a service does not deliver the levels of capacity and performance required, then the business will not experience the value that has been promised. Without capacity and performance, the utility of the service cannot be accessed. The goal of capacity management process is to ensure that cost-justifiable IT capacity is matched to the current and future agreed needs of the business in a timely manner. To support this goal, capacity management has objectives to ensures the capacity plan reflecting the current and future needs of the business is available and up to date, provide advice and guidance to all other areas of the business and IT on all capacity and performance-related issues, ensure that service performance achievements meet or exceed all of the agreed targets by managing the performance and capacity of both services and resources. The capacity management process should be the focal point for all IT performance and capacity issues. Capacity management considers all the resources required to deliver the IT service and plans for short, medium, and long-term business requirements. The process should encompass all areas of technology, both hardware and software, for all IT technology components and environments. Capacity management should also consider space planning and environmental systems capacity. Capacity management could consider human resource capacity, where a lack of human resources could result in a breach of SLA or OLA targets, a delay in the end-to-end performance or service response time, or an inability to meet future commitments and plans, e.g. overnight data backups not completed in time because no operators were present to load required media. In general, human resource management is a line management responsibility, although the staffing of a service desk should use identical capacity management techniques. The scheduling of human resources, staffing levels, skill levels, and capability levels should therefore be included within the scope of capacity management. Capacity management basic concepts. Capacity management ensures that the capacity and performance of the IT services and systems match the evolving agreed demands of the business in the most cost-effective and timely manner. Capacity management is essentially a balancing act, balancing costs against resources needed, the need to ensure that processing capacity that is purchased is cost justifiable in terms of business need, and the need to make the most efficient use of those resources. Balancing supply against demand, the need to ensure that the available supply of IT processing power matches the demands made on it by the business, both now and in the future. It may also be necessary to manage or influence the demand for a particular resource. Capacity management maintains or manages capacity at all three levels: business, service, component. The business capacity management sub-process translates business needs and plans into requirements for service and IT infrastructure, ensuring that the future business requirements for IT services are quantified, designed, planned, and implemented in a timely fashion. This can be achieved by using the existing data on the current resource utilization by the various services and resources to trend, forecast, model, or predict future requirements. These future requirements come from the service strategy and service portfolio, detailing new processes and service requirements, changes, improvements, and also the growth in the existing services. The service capacity management sub-process focuses on the management, control, and prediction of the end-to-end performance and capacity of the live operational IT services usage and workloads. It ensures that the performance of all services, as detailed in service targets within SLAs and SLRs, is monitored and measured, and that the collected data is recorded, analysed, and reported. Wherever necessary, proactive and reactive action should be instigated to ensure that the performance of all services meets their agreed business targets. This is performed by staff with knowledge of all the areas of technology used in the delivery of end-to-end service, and often involves seeking advice from the specialists involved and in component capacity management. Wherever possible, automated thresholds should be used to manage all operational services to ensure that situations where service targets are breached or threatened are rapidly identified and cost-effective actions to reduce or avoid their potential impact are implemented. The component capacity management sub-process focuses on the management, control, and prediction of the performance, utilization, and capacity of individual IT technology components. It ensures that all components within the IT infrastructure that have finite resources are monitored and measured, and that the collected data is recorded, analysed, and reported. Again, wherever possible, automated thresholds should be implemented to manage all components to ensure that situations where service targets are breached or threatened by component usage or performances are rapidly identified and cost-effective actions to reduce or avoid their potential impact are implemented. There are many similar activities that are performed by each of the above sub-processes, but each sub-process has a very different focus. Business capacity management is focused on the current and future business requirements, while service capacity management is focused on the delivery of the existing services that support the business, and component capacity management is focused on the IT infrastructure that underpins service provision. Capacity management key role. Managing the capacity of large distributed IT infrastructures is a complex and demanding task, especially when the IT capacity and the financial investment required is ever increasing. Therefore, it makes even more sense to plan for growth. While the cost of the upgrade to an individual component in a distributed environment is usually less than the upgrade to a component in a mainframe environment, there are often many more components in the distributed environment that needs to be upgraded. Also, there could now be economies of scale because the cost per individual component could be reduced when many components need to be purchased. Capacity management should have input to the service portfolio and procurement process to ensure that the best deals with suppliers are negotiated. Capacity management provides the necessary information on current and planned resource utilization of individual components to enable organizations to decide with confidence which components to upgrade, i.e., more memory, faster storage devices, faster processors, greater bandwidth. When to upgrade. Ideally, this is not too early, resulting in expensive overcapacity, nor too late, failing to take advantage of advances in new technology, resulting in bottlenecks, inconsistent performance, and ultimately customer dissatisfaction and lost business opportunities. How much the upgrade will cost. The forecasting and planning elements of capacity management feed into budgetary life cycles, ensuring planned investment. The key role is capacity manager, who manages the activities like develop a capacity plan and ensuring it is up to date, assisting with the diagnosis and resolution of performance and related incidents and problems, assesses the impact of all changes on the capacity plan and the performance and capacity of all services and resources, ensures that proactive measures are implemented to improve the performance of services wherever it is cost justifiable to do so, sizing new services and systems per future requirements, aligning capacity and demand correctly as per the business needs, optimizing existing capacity. He's the focal point for capacity and performance issues, provides management reports on current usage, trends and forecasts,